Yes, children, welcome to this physics lab. Today we are going to perform one experiment. The object of the experiment is to find resistance of the given nichrome wire by using a meter base. You can see I have written here to find resistance of a given wire by using meter base. The circuit we are going to make use of is this one that I have made on the left hand side here. You can see here that you have the unknown resistance capital R, the known standard resistance is capital S, and you have the resistance between A and C and the resistance between C and D. We are using here the balancing condition of Wheatstone bridge, and for that you know the formula is R by S is equal to the resistance between A and C by the resistance between C and D. Okay, but that ratio would be equal to L by 100 minus L. So the formula that we would be using for finding unknown resistance is R is equal to L by 100 minus L into S. Okay, so AD is a 1 meter wire which is made of a manganese, and we will move this contact point here, that is called jockey. When we find galvanometer, in galvanometer a zero deflection, then we will find the length AC, that will be L, and then CD will be 100 minus L. Now you can see all of these things here in the experimental setup. See children, this is your meter brace. In this meter brace you can see a wire of 1 meter, and it is below this you have the scale. Okay, you have a thick copper strip here, thick copper strip here also, thick copper strip here also. Okay, and this 1 meter wire is given a potential difference by a primary cell which consists of an ammonium chloride solution, a copper rod. See, it is a filled porous pot in which you have the copper rod, around that you have the manganese oxide and carbon dust paste. This is your zinc rod. Now you can see that you have the galvanometer here, and you can see that you have the resistance box here. The standard resistance you will give it by a resistance box. Okay, now I will complete the circuit here by dipping this zinc rod inside this electrolyte and a carbon rod, a filled porous pot inside this solution. Now this zinc rod would act as the negative terminal and this carbon rod as the positive terminal. Now this wire, 1 meter wire, has got a potential difference. Okay, certain potential difference. This potential difference for the open circuit is around 1.4 volt, but when you close the circuit, it will be around somewhere around 0.30, like that. Okay, it will be less. Now I am going to do an experiment here. See, the circuit is completed now. The zinc rod has been completed to it has been joined to one terminal here, and a carbon rod is joined to another terminal here. By in between you have the one-way key. Now this middle point is joined with a galvanometer, positive of the galvanometer. Yeah, one terminal of the galvanometer, another terminal is joined to the jockey as it is in the circuit. Okay, now what will you do? See, on this arm you have the resistance box. Okay, and on another arm you have the unknown resistance. This is of nichrome. Now we are going to take a null point here. So to get the null point, I will slide this between 30 to 70 because we have set the instrument for a null deflection between 30 to 70. Values more than 70, for values more than 70 you have the deflection on one side, for values less than 70 you have the deflection on the other side. For values more than 70 you have the deflection, see it is on the other side. Okay, now from 70 we will move towards the left hand side. So you can see that you are getting a null deflection here at 68.7. so this will be your L value. From here we will take the measurement. So this will be L and this will be 100 minus L, right? Now you can see that I have taken out 1 ohm. I have supplied S is equal to 1 ohm from the resistance box. Now to give the value of resistance from the resistance box, a value of 2 ohm, I will take out the key 2 ohm from the resistance box. Now S is equal to 2 and let us find null deflection for that. It is, you can see it is 52 centimeter. Okay, now your L is 52 centimeter and 100 minus L would be 100 minus 52, that would come out to be 48. Okay, and here S is equal to 2. So all these values, you will put here in the observation table. You can see that you have varied S here, correspondingly you are getting L value, right? And 100 minus L you can calculate and you will use this formula to find the unknown resistance. You will find the average of R to get the mean value of the unknown resistance, which is nichrome here. Okay, so the material is nichrome. Okay, so the resistance of the nichrome wire of certain length and cross sectional area, you will get that value here. You will report in the result that